So let's first remember to add and subtract. You need common denominators. That's the LCM. What's the least common multiple? If you start listing multiples of 3 and multiples of 2, what's the first one that's in common? 6. We have to know a little bit of algebra here, that if we are adding a negative, that's the same as subtraction. And then, of course, 3 times what is 6? It's just 2, so we can multiply by 1 in the form of 2 over 2. Basically, you're reducing backwards. You're saying 2 over 3 will be the answer when you reduce what? What over 6. So what over 6 reduces to 2 over 3? What over 6 reduces to 1 over 2? Okay. It's the reducing a fraction backwards. And you guys know in math, that's a lot of what we do, is we learn how to do something one direction, then we learn how to undo it. Right? So for the longest time, you learned how to reduce like 8 over 12 and then divide top and bottom by this. Now we're multiplying top and bottom. So that's where this happens. So we get 1/6. Okay. And of course, if there was no number underneath, that's the same as a fraction of over 1. So same idea. What divided by 2 equals -7? We came up with -14. That's -15 over 2. And for our purposes now, leave everything as a improper fraction or a proper fraction. Don't make this a mixed number of -7 and 1/2. Just leave it as -15 halves. That's fine. Okay, so yeah. What divided by 5 equals -2? -10. Minus. Alright, good. And we came down here, do a little bit of review of GCFs. Just make sure you know how to factor out a GCF. We got 3x minus 1. And I'll rewrite this as 2 times 4x squared. Just factor it 8 to 2 times 4 so you can see the 2's cancel. Are you allowed to cancel the x's? No. So only when they're being multiplied. It's 2 times 3x minus 1 and 2 times 4x squared. That's why the 2's will cancel. On the bottom here, let's see here. What's a GCF down the bottom here? 12m. So it's very tempting to say 4 or 3 or 2 even, but you have to go with the greatest. Okay. So we have, what's left over? M plus 2. And on the top, yeah, it's 30. I'm going to write this as 5 times 6, though. And the bottom, the 12, I'm just going to rewrite as 2 times 6. So again, I can clearly see these are canceling out. By the way, what does canceling out mean in this context? What does it equal? 1. So these all equal 1. 6 divided by 6 is 1. M divided by M is 1. Don't think it's 0. Because then if there's a 0 here all of a sudden, well, 0 times anything would make it 0. And using that logic, anytime something canceled out, the whole answer would be 0 because cancel out means 0. So it equals 1, not 0. Left on top, 5. Left on bottom, M plus 2. Correct? 2, yeah. So with all this canceling, it's sometimes you can get a little cluttered. So be very careful. Do a full scan. Make sure you didn't forget anything. I've seen plenty of times where all the work is there, and it's just forgotten because it's written too small or it's too messy. Some non-mathematical reason, prevented the right answer from being written down. So keep that in mind. Sometimes it's math, sometimes not. As always, when needed, if if you have a trinomial, use the x as needed. And kind of assume that these are set up for something to cancel, so when there's an n minus 10 on the bottom, start off with minus 10 and see if you can just finish it. Oh yeah, it's plus 4. N minus 10 and plus 4. And nothing left on the bottom. We don't need it as a fraction, just leave it as n plus 4. Alright, good. So let's take a look at some of these we need to add. Of course, we need common denominators in order to add, just like we did back in elementary school. So I'm going to start off with some problems that already have common denominators. So we just have to focus on adding and subtracting the tops. Alright, so same common denominator already, so I know it's 18b. What will the top equal? 5u plus 5v. Okay. Can we simplify this? So basically, can we do what we just did on number 5 through 8? Can we do any factoring? Can we do anything? We can't factor anything? Yeah, let's factor. We got the top. What comes out of the top? Alright, we got a 5. Now, will 5, any factors of 5 and 18? No. So our final answer will just be this. Now the question is, even though I didn't cancel anything, do I have to factor? Yes. Because unless it's factored, you can't tell if something cancels or not. So I don't want you just staring at it thinking, I don't think it's going to factor and cancel and stop. Maybe it does factor and something's the same on the top and bottom. So you have to go through with it every single time. Alright. So, anything else? Alright, go ahead and do those 3 right now. 10, 11, 12. Take a look at number 11. What do we get on the top for number 11? Oh, screen died. Okay, you get 6x plus 3y all over 12y. Now, is that the final answer? No. So if you just have that as your answer and you stop, that's what we were talking about. If you can factor, you have to. So what factors out of the top? 3. So it's 3 times 2x plus y. And on the bottom you can rewrite as 3 times 4y. And then you can see the 2 3's cancel out. Now, does the 2 and the 4 cancel out? The 2 on top and the 4 on the bottom. What about the y and the y? Are you sure? And that's probably the most difficult part about all these problems is, well, am I really done, or is there something else left? So always ask yourself, is what you're canceling being added or subtracted? So if you want to try to cancel the 2 and the 4, say, well, this is 2x plus y. No good. This is plus y. This is times y. Does not cancel. So, yeah, this is our final answer. This is something, this simplifying what we did on 5 through 8. You do that at the end of every problem. It's the equivalent of reducing a fraction. So it's equivalent if we just did this in elementary school and we got 2 over 4. We always had to reduce it to 1/2. That was always the case. So we're doing the equivalent of that right here. After we finish, see if you can factor and then cancel something out. Okay. Please don't be one of those people, or one of those kids, like you were in elementary school maybe, and raise your hand and say, do we have to reduce? The answer to that was always yes, but there's still some people that somehow think the answer changes over time. So no, you always have to reduce. Every single time. No one's ever told you otherwise. So Make sure you always do it. All right, moving on to the back. Denominators are different. So this is kind of like what we did on 1 through 4, but they have variables. All right. So what do we need to do to get these to be the same? Yeah. So to get them to be identical, this will need a y. But now this is just 3y. This is 2y. So we'll also need a 2, which means on the other side we'll need a 3. So that's the process. Just it's the same exact thing. If there was no y there, you would have said, oh, the LCM is 6, and you would have multiplied by 2 and then 3. Now we just have a y there as well. That's the only thing that's changed. So we have, what, 4 y squared 6y minus 15 over 6y, and now that equals 4y squared minus 15 over 6y. The only thing different from elementary school is that now we can't actually, these aren't two numbers. Before we could just say, oh, 4 minus 15 is this. Now we just leave it as 4y squared minus 15. But does that reduce on top? No. But the y's cancel out. Right? No. 4 over 6? 15 over 6? Sorry. Just trying to make a point. No matter how many times I do this, somebody will do it on a quiz or a test. Things just magically start disappearing. Alright. Let's go down to something with binomial. About 17. Now, you do not want to just simply say, well, I'll just multiply this side by 2b minus 10, top and bottom, and this side by 2b. It's too much work because they probably share a factor. So instead of doing that, that only works if both denominators are prime. But as you can see on the bottom here, of the first fraction, it's not prime. It does factor. So you want to factor it first. Now you can see that, alright, this 2 and this 2 is already in common. I don't have to multiply by another 2. Otherwise you would have over here multiplied by 2b minus 10 and over here by 2b. We don't need that because they both already have it in common. But this is missing a b, just a b, and this side's missing a b minus 5. So now they have the exact same factors, all three of them. There's 3 factors here, and they're on both of them now. There you go. So the thing that's different from elementary school is you might have to factor first. Instead of just saying GCF is this, factor first and then make them the same. You're just making them the same. Make them match. Make the bottoms match, multiply what's on top, you're good to go. There are a few pitfalls here. If I had you do this problem right now, you'd probably get, let's see, but don't write this down, but, well, maybe. Tell me if this, is this right? Plus 5, plus 6b, minus 30, all over, let's say 2b times b minus 5. Is that correct? What do I need to do? 5b? 5b. Because, yeah, so it's not explicitly said or written this way, but it's implied that we have to multiply b by the entire top. So add the parentheses in so you don't forget to distribute, because that will change your answer. So b squared plus 11b minus 30. Alright, good. Now we're done, right? Does that factor? No? You sure? What two numbers multiply to 30 and add to 11? Yeah, it's kind of 5 and 6, right? But this is negative 30, right? So 3 and 10? Negative 3 and negative 10? No, nothing like that. So kind of close though. It almost factors. If this was a positive 30, yeah, it would be factoring. So, but otherwise, nope, that's our final answer. So you can see, at first glance, 30 and 11, yeah, you think 5 and 6. But be very careful, one little sign. And that's really where these might become difficult, is because one little sign changes everything. Alright, so any others we need to look at? Let's see here. Any requests? Something that looks different or more difficult? $24. Yeah, what can we do here? Multiply this side by and this side. We need them to match identically. Can this be factored? No. So these are both prime. When they're both prime, you just end up multiplying like that. So 3 on this side. On this side, it's going to be 3p plus 4. 3p plus 4. Yep. Once again, it's implicitly assumed you need to have the parentheses there as well. Okay. And then start multiplying. So we have 3p plus 15. Careful here, we have to multiply 4 times. 6p squared, 8p, minus 15p, minus 20. It's also just known as foiling. Those last 4 is like foiling. And then simplify what goes together, so I can see 3p plus 8p minus 15p, and 15 negative 20. So 6p squared, that doesn't change, right over here. 3 plus 8 is 11. 11 minus 15. 11 minus 15 is negative 4. 15 minus 20. Positive 5.
Negative 5.
Oh, negative 5. Very good. Over 3 times 3p plus 4. Okay. Is that right? Is it right? I want to pay attention. All right, we'll see what happens.
Don't you distribute 3?
All right, we'll see. We'll see how it goes. Yeah, so it's very easy to have everything look just fine, and then we go back and we notice, well, how come it's wrong? We totally forgot about the minus sign. So we did this on purpose just so you can see how comfortable you get doing these, and they might just seem easy, but one little thing makes it way different. So we know that this isn't going to be correct anymore, and we have to go back and distribute a negative to everything we just multiplied. So these 4 terms are really all the opposite sign. They're all negative. So this is really negative 6p squared, negative 8p, positive 15p, positive 20. Alright, so now our final answer for real is going to be 6p squared. Okay, now it's going to be 3p plus 15, right? That's 18. And then 18 minus 8 is 10. 10p. And now we have 15 plus 20, which is 35. And there is our answer. So of course, there is a possibility, though. Does 3p plus 4 go into 6p squared plus 10p plus 35? Maybe this factors and it cancels out, but if you look closely, you can say, yeah, 3p, maybe 3p times 2p equals 6p squared, but what times 4 is going to equal 35? So there isn't anything that works there, so we're probably safe with this answer. But if that last number was like 28, I would have been suspicious and tried to go through and factor it. So we always have to be looking for things that factor. Okay, that's out. Those last two terms turned out to be wrong. Alright, good luck.